Hello viewers, in today's class we are going to discuss one important application of vectors in trigonometry, right? So here we are going to derive an important formula that is known as cosine formula for triangles using vectors, right? So let us start and let us first see what do we mean by cosine formula. Now suppose we have a triangle, say ABC, right? This is a triangle and let the vertices of the triangle be A, B and C, right? And if this side BC has the length A, this side AC has length B, and this side AB has length C, then we have three cosine formula for this triangle AB and C, right? So the cosine formulas goes like this. We can write cosine of A is equal to B square plus C square minus A square divided by 2 times of BC, right? And similarly for this angle that is cos of B, we can write A square plus C square minus B square divided by 2AC, right? And for this angle we have cosine of C is equal to A square plus B square minus C square divided by 2 times of AB, right? So these are the three well-known cosine formula related to a triangle ABC having sides A, B and C, and if the perimeter the semi-perimeter of this triangle is denoted by S, then we have this relation that is A plus B plus C divided by 2, right? So here we are going to derive this formula using the concept of vectors, right? So while applying the concept of vectors, we'll apply three concepts, right? So the first one is the triangle law of addition of vectors, right? Triangle law of addition of vectors, right? And the second concept will be the dot product of two vectors, right? Dot product of two vectors. And the third concept is square of a vector. Square of a vector is equal to the square of the magnitude of the vector, right? So to derive this formula using the concept of vectors, we'll use these three concepts from vectors, right? So let us start. So now let us represent the sides of the triangle ABC with the help of vectors, right? So let us take this side BC as the BC vector, right? So BC vector is equal to vector A, and then we can take this vector or this side CA as the CA vector which is equal to vector B, right? And here this side AB can be taken as the vector C, right? So now instead of ABC we have the three vectors A, B and C, right? So now the magnitude of these vectors can be represented like this. That is, magnitude of vector BC is written like this, and we have the magnitude of vector A here. We can simply write it by A. Similarly, here we have the magnitude of vector CA, which is written like this. Here we have magnitude of B, which can be written simply as B. Similarly, here we have the magnitude of vector AB, that is the magnitude of vector C, which can be written simply as C, right? So these are the notations which will be used to derive this formula. Now let us apply the triangle law of addition of vectors to this triangle, right? So we can now write vector BC plus vector CA is equal to a negative of vector AB, right? So here by using this triangle law of addition of vectors, we can write vector BC plus vector CA is equal to negative of vector AB, right? So BC vector is equal to A, CA vector is B, and here we have the vector AB as C, so here we have minus vector C, right? So now if we take this vector to this side, we have vector A plus vector B plus vector C is equal to 0 vector, right? So this is an important relation in a triangle ABC where the sides are represented by the vectors A, B and C, right? So in order to derive all these three cosine formulas, we have to make use of this result only, right? So here in this lecture we are going to derive only this one. So here we see that cosine of A is equal to B square plus C square minus A square divided by 2BC, right? So here we see that in the denominator we have the product of B and C, right? So from this relation what we will do, will take this vector A to the right hand side, right? Similarly, if we have to derive this vector, this relation, here we have the product of A and C, right? So in that case what we will do, will transpose this vector B to the right hand side, and similarly to derive this result, here we have the product of A and B. So we'll retain A and B to this side only, and we'll transpose this vector C to the right hand side, right? So here we have BC. So what we will do, we'll retain B and C here, and we'll take this vector A to this side. So here we have negative of vector A, right? So from this relation we see that the sum of the vectors B and C is equal to the negative of the vector A, right? So let us take the magnitude of both sides, right? So what we will get, we'll get the magnitude of vector B plus C is equal to the magnitude of minus vector A, right? So this is simply equal to the magnitude of vector A, right? Okay, so now here we see that we have the magnitude of vector B plus vector C is equal to the magnitude of vector A, right? So these two magnitudes are equal, right? So now what we will do here, we'll take the square of both sides, right? So what we will get, we'll get magnitude of vectors B and C square, and here we have the square of the magnitude of vector A, right? And here now we'll use the concept of square of a vector is equal to the square of the magnitude of vectors. So from vectors we know that if we have a vector say D, then the square of this vector D is equal to the square of the magnitude of this vector D, right? So here we have the square of the magnitude of this vector, so we can now replace the square of the magnitude of vector b plus c is equal to vector b plus vector c whole square, right? And here if we again use this result, then the square of the magnitude of vector a is replaced by simply the square of this vector a, right? So now this relation can also be written like this. Here we have the square of the sum of the vectors b and c. So now we have to use this concept of dot product of two vectors, right? So we can now write this expression as vector b plus vector c dot vector b plus vector c, and here we can write square of the vector a as a dot a, right? So now let us multiply these two vectors, right? Okay, so first we'll take the dot product of this vector and the sum of the vector b and c. So we have vector b dot vector b plus vector c plus, then we'll take the dot product of vector c with this vector, right? So here we have c dot vector b plus vector c, and here we have a dot a, right? Okay, so now here we have the dot product of these two vectors, so we can write vector b dot vector b plus vector b dot vector c plus vector c dot vector b plus c dot vector c, right? And here we have a dot a, right? And now if we look at this relation, we see that here we have b dot c and here we have c dot b, and we know that the dot product of two vectors is commutative, right? So b dot c is equal to c dot b, right? So now we have here b dot c, and here also we can replace c dot b by b dot c. So now we have b dot b plus 2 times b dot c, right? Because here c dot b is replaced by b dot c, so we have 2 times of vector b dot vector c, and here we have c dot c, and here we have vector a dot vector a, right? Okay, now here we'll apply one more property, that is if we have a vector x, then x dot vector x is equal to the square of the magnitude of vector x, which can be written as simply x square, right? So here we can write simply b square, and here we have 2 times vector b dot vector c, so we can write bc, and then cosine of the angle between vector b and vector c, right? So for finding out the angle between vector b and vector c, we'll go to this figure. So here we see that if we extend this vector b like this, then here we have the vector b going like this, and here we have the vector c going like this, right? So we have the vector c like this and vector b going like this, right? So this is the angle between vector b and vector c, right? And see, here we have the angle a, right? And by the concept of linear pair, this angle would be pi minus a, right? So here the angle between vector b and vector c is equal to pi minus a, right? And now here we have c dot c, that is simply equal to c square and here we have a dot a, that is simply a square, right? So now we have b square plus 2bc cos pi minus a plus c square is equal to a square, right? And now from trigonometry we'll use the result, that is cos of pi minus theta is equal to minus cos theta, right? So cos pi minus a is equal to minus of cos a, right? So here we have now b square minus 2bc cos a, and here we have c square, that is equal to a square, right? And now if we rearrange this expression, we'll get b square plus c square, taking a square to this side and taking this term to the right hand side. So we have 2bc cos a, right? And now we can write cos of a is equal to, taking this term to the denominator, so we have b square plus c square minus a square over 2bc, right? And this is the cosine formula, right? So out of the three cosine formulas, we have here derived this formula using the concept of vectors.